Hi folks, happy Friday. We've got question 10 from not the integral exercises, the textbook exercises. We were asked to write the fraction on the left in the form on the right. We'll notice that already a small error has been made by our guest presenter. That's better. It's an identity. That means that no matter... Well done. Identity. Yes, that's it. So, no matter the values of x, it is always true. So, I wonder if we'll run out of space, and we should have gone the other way around. There's a spider as well. How lovely. Goodness me, 40 seconds in and nothing done. Right, so we'll multiply through by x, take 1 all cubed. Squared. We've done well here already. Just the 1, and then just c on its own. Lovely. And we'll notice again, we've still got that identity in there with the spider's legs. I wonder how long this will last for. Right, so what should we do? If we choose a value of x being 1, then we get 2. Apparently I'm saying everything. 2 take away 3.
Because I can't square 1. 2 take
2 take 3 plus 4 is identically equal to c. Because our first bracket would be 0, second bracket would be 0. Some basic maths, which I'm not very good at. We've got our value of c. Lovely. Now we need to try and find our values of a and b. So let's start by, perhaps let's try putting in equate coefficients of x squared. Let's do that.
Coefficients of x squared. Okay,
coefficients
so on
of
that
x squared.
side the coefficient of x squared is 2.
2, yeah.
On
the word equate, just in there.
why? Okay.
Because so we're showing what we're doing.
Equate.
Equate.
Right. On this
coefficients.
side, I'm going to get x.
Coefficients.
I haven't got room for coefficients.
Okay.
Coefficient
of x squared.
X squared. Right. There I'm going to get x squared because it's going to be ax squared. And that's it.
It is. It's a coefficient, so we just want a. And then we've now got terms, so we could change terms. But we've got a equal to 2.
Yeah, we have.
Excellent. Good. And then another smiley face because they're important. Okay.
And a mouse.
Oh, and a mouse. Brilliant. All right. We could now maybe equate coefficients of x, but we're not going to do that because that's just going to be a little bit harder. We'd have to expand that x take 1 squared. So instead, we're going to use the fact that it's an identity, and we're going to chuck in the value of x as 0. So our left-hand side becomes 4. Our right-hand side becomes a plus negative b plus c. 4 then is identically equal to 2, take b, plus 3. And then I'm not actually capable of that maths very quickly.
1. No. Negative 1.
5. 5 take away b.
Hang on, I seriously can't do that. 2 add 3 is 5.
5 take b. So that makes b is 1. B is 1.
B
Excellent.
Is 1.
Good.
Woo!
Now we're asked to write it in the form, so we'll just finish the question off and we'll write, there we go, 2x squared take 3x plus 4 over x take 1 cubed is identically equal to 2 over x take 1 plus b, so plus 1 over x take 1 squared, and then plus 3 over x take 1 cubed, and that identically equals there. Good, wonderful. Big smiley face. All right. Then part B, because there was a part B to this.
You're joking me.
No, there's part 2. Hence, find the first 3 terms in the binomial expansion of that, stating the values for which it is valid. Oh, lucky us. Okay.
That's like loads of work though.
That is.
Go on then.
It's all right. All right. So, we've got 2 over or 2.
We're not.
Yeah, we are recording. It's still there.
No, but we can't see what we're doing.
I can see it here. It's all right. Oh dear. Right. So let's take them in turn. So we're going to get 2 lots of x take 1 to negative 1. Let's expand that.
Oh, we're just doing that
we're just
first,
do that.
do we? Okay.
Yeah.
All right then, let's do that.
Yeah. And 1 plus
the power times... Oh, it's the wrong way round. I don't like that.
Okay. Negative 1 plus x.
But doesn't it have to be 1 plus?
Okay.
Doesn't it?
Yeah, you got a negative 1 there. All right.
So Jake, what do I do with that?
Well, we've got to take the negative 1 out, don't we? So we can take a negative 1 out. Yeah,
Okay.
that will work.
Right, so we're actually expanding this then.
So we're expanding that there, yeah.
Okay,
so it's
so
1.
negative 2.
Negative 2. 1 plus...
Oh my god. How far do we need to go?
I
First
don't know.
3 terms.
First 3 terms, I think.
We're still going to be here forever.
I know.
Okay, minus 1. Sorry, negative 1.
Negative
2.
1.
That all squared over 2 factorial.
Mm-hmm.
And tidy that up.
Yeah.
Negative 2, lots of 1 plus x plus x squared.
Yep. Cool.
That's that bit.
Mm-hmm.
Right, then this bit
Mm-hmm.
is 1, and it's not over. Why am I writing over? X take 1 to the negative 2.
Mm-hmm.
So,
And when they're thinking about the negative, it's going to be the negative version.
Negative 1 take x to the negative 2.
Yep.
So it's negative. Is it the same thing?
It's the same thing. Yep. So we've got 1.
Plus the power to that. Did you say it was 3 terms?
Yeah. 3 times.
Power take 1, that squared over that factorial.
Mm-hmm.
Are they actually filming this?
Yeah, it's filming. That's right. Sorry, we've got the question on the screen, so that is still
So
there.
upsetting me. I can't see what I'm writing.
Okay.
Okay.
Anyone think it wasn't in front of you? Never
It's not in front of me. 1 plus 2x. Bear with. Just patience. Plus 2 divided by 2 is 2. 3x squared.
Good. And then we've got the negative.
So I'm expanding that out. I did
That's
that here. Do you want me to expand?
That's not that. We'll do it all later then. We'll expand it
right.
later. Okay. That's
we'll
all
be
good.
consistent
Yep.
in our incompetence. Lovely.
Let's do it. All right. Then we've got 3 over
Where are we? This one.
this one.
Okay.
Yep.
So that is going to be 3x take 1 to the negative 3, which is negative 3. 1 take x to the negative 3.
Good.
Which is negative 3.
3.
Lots of 1. I'm bored.
Yeah.
Take 3. So plus that
Yeah.
times that
Yeah.
plus that times
That we've got power in there as well, and the power take
2
1.
factorial. Okay.
There we go.
Equals negative 3 times 1 plus 3x plus 12 over 2 is 6 x squared.
Good. Okay.
That's just a crazy mess.
It is. So which ones are we adding up? Hang on. So we're going to add up
That one.
the negative. So it's got a negative here. The square brackets are good. Sometimes when you think about square brackets, that you've still got some work to do. Plus that one and that one. They're all negatives. So we've got, should we expand this? We've got negative 2, take 2x, take x squared. Or 2x squared even, because 2, you shouldn't let me do maths. Shouldn't let me do maths.
And I doubted
I know.
myself.
Alright, so take 1.
So we're adding take 1.
Yeah. Take
Okay.
2x, take 3x squared.
Yeah.
And then
I've written too big.
take 3, take 9x, subtract 18x squared. There for me. Okay, so what's that?
I don't know. Negative 2. Take 1. Take 3 is negative 6. I'm actually just going back to year 7 teaching.
It's good.
Negative,
Oh, you've got the same colours. It's different colour, same colour. There you
X
go.
is
Yeah,
2, 2 and 9 is...
they're all negative as well. So
I still
take.
can't do that. 13.
Good.
13x.
Yep.
Different colour pen.
Yep.
Negative 2, negative 3 and negative 18
Mm-hmm.
is negative 22
Mhm.
x squared. We need to do the validity, don't we?
Yeah, unfortunately, I've just looked at the answers. It's negative 4, take negative 9x, take 17x squared. Okay.
Right. Where have we gone wrong then?
Oh, I don't know. I haven't actually been paying much attention to anything. Where have we gone wrong?
Can we pause the video?
Let's pause the video. We're going to pause the video and figure out where we've gone wrong. Okay, and we're back, and I've just discovered there's a pause button, which would have been really, really useful for many of the previous videos. We discovered that our mistake came from this second expansion.
Who discovered?
We discovered that the mistake came from the second expansion.
I discovered.
She may have done. She's going to explain that. Anyway, moving on. The negative 1. We're going to expand this negative. No, you're not. We're expanding this thing here.
Yeah,
That
this
second
is
term.
wrong because we did this wrong.
Yeah.
So we need to go back and look again at why this does not equal that.
So
starting.
So if we start with 1 over...
I'm just trying to... Yeah, alright.
1 over...
Right, we're trying to work out how to do that because we messed it up last time.
Well, you can... Yeah, okay. 1 over x take 1 squared. There are two ways to look at this. Our first way, what we're going to do, is we're going to write this as that.
So inside the bracket we're going to factorise this bit and say I want that with 1. That's got to be 1. So I'm going to... divide... No, it's not. That's a negative.
Oh yeah, you're right. Sorry.
So I'm going to pull a factor of negative 1 out, but the power is still negative 2 for the whole thing because this bit equals this bit. But when you pull that factor out, I'm saying I want this to that power, so negative 1 all to the negative 2 times that to the negative 2. That's just going to be 1 take x to the negative 2. Now that, convince yourself of that. Negative 1 squared is 1, and that's the reciprocal, so it's 1 over 1, it's just 1. Really think about that carefully. Okay, there's the second way of doing it then.
I've just realised that I would have worked that. Don't worry about the second way for now. We're going to keep it this way.
Okay, right. We're going to go with this way. Okay, that's all good. Right, so if we realise that that bit then ties into this bit of working here that we've done wrong, we're going to redo this middle fraction that we did. So we get 1 plus the power, second bit plus the power minus 1, second bit squared over 2 factorial. So then we got our 3 bits to add up again, haven't we?
You tidying that one first?
Yeah.
Tidy that.
Go on then.
Oh, me. Oh, okay, sorry. Yeah. So that's 1 plus. We're going to have 1 outside the brackets, are we?
Yeah.
Okay. 1 plus 2x. And then that's 6 over 2 is 3, so 3x squared plus 3x squared. Cool.
Which is actually what we got before, but obviously without the negative outside. It was the negative that was the issue.
So,
need paper.
Need more paper. You want this?
No, I've got paper.
Got paper. Alright. Moving on. This was a quick question, by the way, 12.5 minutes in. Right, so...
So we want to add up this, and this bit.
That one.
And that bit.
Yeah.
And it's almost exactly the same as we did before, so I'm not going to bother doing the whole caboodle again apart from these 3 terms, just changing them to positive. It's negative 2, take 2x.
Take 2x squared, then plus 1, plus 2x, plus 3x squared, take 3, take 9x, take 18x squared. And that all tidies up really, really nicely to negative 4, take 9x.
I've got to do colours.
Oh, sorry, we're going for colourful.
Oh yeah, they're going to cancel. Okay.
They are. It's going to take 9x. And then our colourful things there will show us that we end up with a negative 6x squared. Okay, and then the validity. That's not
6.
17, sorry.
It's
17.
Not 6.
17, sorry. I may have been reading the question from above. Alright.
Right, validity.
Validity.
3 things we expanded, yeah.
Yeah, so validity is something that you should get used to stating. Whenever you do a binomial expansion, state the validity. They've all got the x take 1 in the expansion as the denominator. Okay, and therefore, for all of the terms that we got, where was the original thing we're expanding up here? All of these here have got the x take 1 on the bottom, so the validity will just come out as mod x being less than 1.
See, I've done it for that way. That's the thing I expanded. I go back to what did I actually expand? Expanded that.
Yeah.
This bit here has got to be, the modulus of that's got to be less than 1.
Which,
so it's exactly what you just said.
Yeah, so mod x less than 1, which we might write as 1 and negative 1 like that. Lovely. Oh, excellent. More video solutions available upon request. Thank you.